Now let's move on to example number 2. If you are yet to watch the first video that includes the introduction, then consider checking the link that is in the description of this video tutorial, as that will actually redirect you to that introduction video. That will give you a clear insight of the basic idea behind rational inequality. So the second practice or example problems we have is this. We have x plus 1 divided by x plus 2 to be greater than or equal to 0. So our first step is to make sure that what we have at the right hand side is 0. So since we have it to the 0 already, then that part has already been cleared. And the next step is to get the critical points. To get the critical points, we set both the numerator and the denominator, we set them to be equal to 0, and so for x. So we have x plus 1 equals 0, and x plus 2 to be equal to 0. Now note that x plus 2 cannot be 0, because if it is 0, the expression on the left hand side will become an undefined function. We are only doing this to get the critical point, that is, a value that x will be approaching. It could be the value, it might not be the value, just as in the case of this, x can never be equal to minus 2. So we have x to be equal to minus 1 if we bring the 1 to this side, and we have x to be equal to minus 2 if we bring this positive 2 to the side. So now let's draw the number line to get the different sections where we have the solution. So minus 2 comes before minus 1. So we have first section, second, and third. All the way to the left is negative infinity. All the way to the right is positive infinity. Now, in between negative infinity and minus 2, we have infinite numbers, infinite negative integers. So let's just select minus 3, because that's actually towards the left. So if we plug in minus 3 as x, let's note what the behavior is going to be. So we have minus 3 plus 1 divided by minus 3 plus 2. So that's minus 3 plus 1 is minus 2 divided by minus 3 plus 2 is minus 1. And if we divide that, we should get 2. Since 2 is obviously greater than 0, then this section is part of the solution that satisfies this inequality. Now, in between negative 2 and minus 1. Now, we have to be careful, because we have greater than or equal to 0. It means the x value would be equal to one of the critical points. So for you to know which is going to be equal to, usually it should be equal to the critical point we have when we set the numerator to be 0. The reason is because if x is that value, which is minus 1, minus 1 plus 1 is 0, and 0 divided by whatever this is, we'll have 0. Well, the reason why x cannot be minus 2, which is the critical point we get when we set the denominator to be 0, is because if x becomes minus 2, then the denominator of that expression will become 0, which with us result in an undefined function. And we don't want to do that. We don't want to have that. So we can circle this point and shade it to show that x can actually be equal to minus 1. Okay, why this can be left as open circle. That x cannot be equal to minus 2. Let me just put that. Okay, perfect. Now, let's select a point in between minus 2 and minus 1. So let's say negative 1.5. Negative 1.5. Okay, so if we have, this can actually go at this point. This can go. If we have negative 1.5 plus 1 divided by negative 1.5 plus 2. So negative 1.5 plus 1 is negative 0.5, and negative 1.5 plus 2 is what? Positive 0.5. If we divide these two, we should have negative 1. But negative 1 is not more than 0. So there's no solution within this region. Am I communicating? Excellent. So in between minus 2 and minus 1, we have no solution. Now, the last section, in between minus 1 and positive infinity. Let's work with 0, because 0 actually falls within this region. So if we plug in 0 as x, what would happen? What would we have? So we have 0 plus 1 excuse me, divided by 0 plus 2, that becomes 1 over 2, which is actually 0.5. Since 0.5 is indeed greater than 0, that means this is also part of the solution. Now remember, we said x will also be 1. So why did I think, okay, let me just show you something. That what I want to just point out is that we need to make sure we include this, because it's part of our solution. So in interval notation, the solution is coming from negative infinity all the way to minus 2. But it doesn't include minus 2. So we still use a parenthesis to close the bracket. So this includes union. Now it's starting from minus 1, because x can be minus 1. You feel me? X can be minus 1. So it's starting from minus 1. So don't use a parenthesis to begin. Instead, a closed bracket to signify that the minus 1 is part of the solution. And this ring all the way to positive infinity. And close that with a parenthesis, because who knows where the infinity is? Nobody. So that is actually the solution in interval notation. But in inequality form, we can set that x is less than minus 2. That goes all the way to the left from minus 2. So we don't have to include the inequality sign, sorry, the equal sign, because x can never be minus 2. And x is greater than or equal to minus 1. So that's that from minus 1 and go all the way to the right. And that's that. So that gives us the solution to this problem. And this is how you can easily and mentally find the solution to a given rational inequality. I hope you find this helpful by now. I want to believe you should be able to start updating and upgrading your understanding in rational inequality. Now, let's consider a few more practice problems for better understanding. So, there we are. So, example number 3. Given that x plus 3 divided by 2x minus 3 is less than